We've hit the top of the hour. I'll begin with the chair slides. Jeff, if you'll advance it to the next one. Welcome to IETF 111. This is the note well. If you haven't read it before, take a moment, download the slides and read it. All contributions are subject to the rules of RC 5378 and 8179. So take a look at it. It's wonderful reading. We'll go on to the next slide. The quicker I do this, the more time. The slides and the status are online. That's nicely, it's not presenting well, but if it works for everyone else, it's great. Jeff, if you need the status, I send it out ahead of time so we don't worry about it. You can see it on our wiki. So take a look at it there. We have 2 sessions this week. Go ahead. Hopefully, there it goes. We have some potential interims. The first interim I would like, and I'd love to get feedback, is that I'd like to listen to a few drafts that we sort of ran out of time to listen to and suggested we might want to. So we'll call an interim on 8/23 listening to the new drafts, which means if you have a new draft and you've had trouble getting it through working group adoption, or if you'd like a little extra time, I'll be a chair listening along with the other chairs on the 23rd, as you might want to talk about it with the working group. Couple drafts that I had hoped we'd catch up in interims between sessions was Wang RDR, RDORF, and the VPN. Now, they may do a great job and feel they don't need listening or extra time, but I'd like to hold one so that if you've got too short of time, you can do it at a different draft. That'll happen in August 23rd. I have also put out a flow spec v2 spec. It's a drafty draft, but since we're moving toward flow spec, I've garnered another editor, and we may get add a third one in Christoph Loeb, who did the first V1 spec if he has time. The next 2 I'm giving you some dates we'll hold open in case we have some of the other issues. These interims proved to be useful during the summer on flow spec and BGP auto configuration, so we're going to tee these up in the fall. If we find we don't need those dates, we'll let you know. If there's any problem with these dates, or if you have a topic, please let me know. Otherwise, we'll ask the ADs to reserve some of these dates. Again, this is more of our efforts to try to progress our work as quickly as possible. We have a lot of requests for flow spec, so we're going to try to move flow spec v2 along very quickly. Okay, could you go on to the next slide? This talked about the interims that we had. There was one on the 7th on BGP flow spec. We found out that people really wanted us to focus DDoS applications in V1 and all else in V2. On the wiki, we'll find out if you had a draft, whether it's in V1 or V2. I won't walk through it, and I will assume that authors will go see it on the wiki. The auto configuration. Also, we found that draft IETF IDR BGP out of conf considerations captured most of the knowledge. I've sent out a request for adoption. We've not heard much. I think that's because we heard all of the feedback during the interim. So unless there is a problem, the chairs will adopt this. I realize it's got an IETF name that was initially erroneous, but we're going to go ahead and drop it as a working group draft since it does encapsulate what we've heard in the interims. This will become a working draft on Friday unless we hear some problems. Okay, Jeff, let's try the next presentation. And the next one, Jeff, I'll let you pick up and discuss with the car DT selections. Is that okay? And
that's fine, Sue. As part of the work that is happening via Spring about some flavor of what was originally labeled as either classful transport or color aware routes, motivated mostly by work that's happening in Spring. Since we have two BGP solutions that are currently out as proposals, we asked the authors of the existing protocol drafts 4 questions that we'd like to have them discuss as part of their presentation. The question 1 is basically, where does your mechanism carry the intent? Question 2, when the intent needs to go from one domain to another, how do you handle that? Question 3, how does route selection impact your mechanism at pinch points? And question 4, how are you carrying the forwarding semantics, as an example, labels or sets? So that is the chair slides. I will be switching over to attempting the new mechanism that MeetEcho has suggested to see if we get better presentation. Sue, please be aware that we are getting a little bit of warble from your audio.
warble or not?
Yeah, your audio is not staying clear.
Okay, I'll stay off audio most of the time then.
Okay, and MeetEcho, I am trying the presentation view and not getting anything, so I'm not sure exactly what is being looked for.
Need to first click on the settings and manage slides and ask for a conversion by clicking on the right button.
Okay.
And then on the left side under your name, there should be a ask to share slide option that you can click on.
Thank you. I am in the process of doing so, and hopefully will not waste too much of the working group's time completing this. Okay, the conversion has been done. Okay, Mahesh, how did you actually do the display?
So on the left side under your name, you see those 5 buttons to unmute, mute button. There's one option which is ask to share slides.
Show preloaded materials, thank you. So I am sharing the BGP Yang model. Let's see what happens.
All right, should I start?
You should feel free to continue.
All right. So I'm presenting the status on the BGP Yang model on behalf of the authors. Next slide, please. So the status on the -11 version of the draft, we went and restructured the model, not only to reduce the number of submodules. There were some really small ones that really didn't need to exist as separate modules, but also looked at it structurally to make sure that that the model was extensible, could be the groupings within the model could be used by other models that wanted to extend the BGP model. And with all that cleanup, and we posted -11 version. It also has examples that show how to add a new AFI, slightly more extensive example. So that should allow authors, other authors to be able to see that example and extend. There's also an example to add new attribute set in the appendix that people can take a look at. And we did address and incorporate most of the comments from Yang Doctor's review. Thanks, AC, for doing the review. We still have a few issues to resolve. And next slide, please. So the issues are being tracked at this GitHub location. And so if anyone wants to see what is still outstanding or wants to file new issues, it would be a good place to go and do that. There are two major issues that we do want to discuss in this meeting today, relate to extended communities and large BGP communities, that I am going to actually let Jeff talk about. So Jeff, back to you.
Okay, thank you. So very briefly, I do encourage anybody that is following this work and interested to please take a look at the GitHub issues. We are trying to follow IETF process, even though this is not necessarily in an IETF GitHub at this point, given the history of the documents. And we're trying to track known issues there. The two largest issues that we have to be done at this point is working in reverse order. Large BGP communities has become, since we adopted the work, a well-deployed and sort of pervasive feature, and we want to make sure that it's included as part of the base model at this point. It's not necessarily difficult work, but it's not small, so it is not currently in the version that has been pushed to IETF. The second issue, and to some extent what Mahesh was hitting at in the prior slides, a big portion of the exercise we've been going through is making sure that we are capable of extending the model and maintaining it. And we found a couple of small issues that caused us to do some of our reorg. One of the issues that's going to be problematic, and will also hit other working groups as well, is what to do about things that are in the form of a Yang type def. Type defs currently cannot be augmented. They have to be effectively replaced. We're going to go forward with trying to code up a solution for this that effectively moves the extended communities into a IANA maintained module. What this will mean is that anything that wants to add extended communities would effectively need to coordinate through IDR, and we would maintain the module in IANA as our way of taking care of this. This is going to be effectively a piece of new and somewhat more iterative work than has been done in other Yang drafts at this point. So part of this will also be working through what the process looks like across IETF. Back to you.
All right, next slide. So as Jeff mentioned, so we kind of looked at all the structural issues and have tried to address most of them. We also looked at interfacing with other modules, whether it's BFT or TCP, and I believe at this time that the model is compatible and can support BFT and TCP. We do, as already said, we do have some issues that we need to take care of before we can ask for a last call. That's pretty much it.
We have time for questions if there are any. Okay, if you have no questions, the request is for you to please take a look at the work in progress along with the open issues. If you have time and know something about Yang and GitHub, please feel free to take an issue and supply a patch for it if you think that you have a solution for things. Otherwise, the authors will continue iterating, and target is to try to have things largely done by next IETF. Thank you, Mahesh. Okay, so our next presentation is BGP color aware routing. DJ is the presenter with 10 minutes of time.
Hello.
Hello, we can hear you. I'm in the process of sharing.
Okay, great. Thanks, Jeff. Hello, everybody. I'm Dhananjay Rao from Cisco, and I'll present on behalf of the BGP CAR co-authors. Next slide, please. Quick recap, BGP CAR extends hop-by-hop BGP routing to set up an intent-aware path across multiple network domains. It directly adopts the color construct that has already been defined in the IETF to represent intent and supported by multiple protocols. Next slide, please. It's a quick illustration of the basic flow of both the transport, where a BGP CAR route propagates hop by hop across the domains to an ingress PE, and subsequently the automated steering of a colored service route, that is a service route with the color extended community, resolving over this BGP car route. Next slide, please. So the next few slides will cover some of the core concepts again, as requested by the chairs. Next slide, please. The car NLRI is simply the endpoint, which is the IP address, followed by the color, which is a 32-bit value that represents intent. The color serves two purposes here. It acts as a distinguisher to create a unique per intent route for an endpoint that can propagate end to end. And it also indicates the intent provided by the route. And here we, intend or expect the color to be configured, and the mapping to be consistent across a set of devices that can span multiple network domains, but they all fall within a single, administrative authority, so a so-called color domain. Next slide, please. Why this model? It is the simplest data model that addresses both the uniqueness and intent requirements. It is also semantically identical to BGP routing used in the underlay, whether for IPv4, v6, or for BGP LU, which is the more pertinent use case here. We just add color to the route. Hence, it provides the familiarity and the simplicity for both the implementation, but more importantly, operationally. There are no complex procedures involving VPN, our import, export, or RD manipulations here. It also provides inherently, automatic multipathing and fast convergence, as we'll see in the next slide. Next slide, please. So this example shows both the path availability, as requested by the chairs, as well as the local convergence, property. You have two ABRs, 231 and 232, originating a BGP car route E3C1 for an egress P E3. Because you've taken the MPLS example, the labels allocated are different. Now, at a transport RR within the domain, add path would be enabled to ensure both these paths are distributed to the ingress baud routers in the domain, for example, 212. Now, if you look at 212, these two routes automatically become multiple paths, providing either ECMP or active backup capability. The node allocates a single local label, and then when it has to propagate this route upstream, it advertises that local label with the next hop as self, and this process repeats. All of this is identical to what happens with BGP LU today. And to see one of the benefits, when the egress ABR, that is 231, fails, that failure is detected locally within the domain via IGP, so that's fast. And the the handling is local, again within the domain at the border nodes such as 212. There is no propagation of the failure, upstream into other domains. This is not possible, with the NLRI scheme that leverages an opaque RD. Next slide, please. To answer the question of how different color domains are supported, this is where the color mapping value changes across some boundary, typically a BGP peering boundary. An optional extended community called the local color mapping community is defined. It only gets used if the routes go across the color domain boundary, and it's used to remap and rewrite the color into the receiving domain's color at the domain boundary, again at a peering session typically. Likewise, the color extended community, which also which would be sent with the service route and would also go across such a color boundary, would get a similar kind of remap and rewrite operation. One thing to note is the NLRI itself does not get rewritten. It is preserved end to end, providing visibility as well as being used for a resolution at an ingress PE. The endpoint IP is unique in the transport. It represents a node in the transport. Hence, this makes the NLRI, the e-commerce C tuple, unique, even if the color is local to a color domain. Next slide, please. With regard to the question about how forwarding information is signaled, it is signaled, along with the route, information such as labels or SIDs. They are signaled with the route as non-key data. Again, this is conceptually similar to what happens with, for example, BGP-LU, where the label is non-key data. What we have done here, though, is we have introduced, because this is a new SAFI, we have introduced a well-defined structure such as a TLV to encode this information. Now, this model then provides one additional benefit, which is not necessarily to be used, but it provides that flexibility, which is one can signal a different so-called label value for different encapsulations. Current label SAFI implementation definitions allow for only a single label, and that has proven to be constrained when multiple encapsulations have been introduced and needed to be supported for migration and interworking. So we see a benefit of this TLV mechanism, which can be leveraged. Next slide, please. What we saw in the previous slide was an example, or one instance, but we have taken this approach of defining an extensible future-proof encoding in general for the NLRI. Since this is a new SAFI, there isn't a need to inherit all the constraints that exist with current label or equivalent SAFIs. We have gone through the different extensions before, so I will skip it in the interest of time, but it's documented in the draft. Next slide, please. Again, BGP car is just routing, so naturally resolution is recursive, but now additionally is color aware. The color aware path for the BGP next hop may be provided by any other color aware mechanism, such as SR policy, IGP flex algo, or another BGP car route itself. But given that it's recursive, the resolution may also be mapped to existing legacy mechanisms, whether it be RSVPTE or even BGP-LU. So there's no constraint from the protocol point of view with respect to introduction into brownfield environments. Next slide, please.
1 minute time check.
Oh, okay, sure. So quick now onto some of the newer updates. So one update is we have described a use case of extending CAR to the VPN service layer, enabling CAR between the CE and the PE and creating an end-to-end encapsulation. The semantics are identical to that supported by RFC 4364, except that this is a new NLRI. It's a CAR NLRI, so it needs a new SAFI. But in terms of how a VPN CAR NLRI gets built, it's a straightforward concatenation of the VPN RD as is done today for any CE route. Next slide, please. This is just an illustration of the VPN CAR model that I just described. I think in the interest of time, I'll skip past it. Next slide, please. Other minor updates, we added some description of how Anycast gets leveraged with CAR for some of the scaling designs, and we also added Jim Richard as a co-author. Next slide, please. So finally, so we plan to continue to address the use cases and requirements that were listed in the problem statement. As usual, we request collaboration and review from the working group. One thing to note is there is, as mentioned by Jeff, there is work ongoing regarding merging the two problem statement drafts at the behest of the various working group chairs. So we expect a discussion about progressing the solution once that effort is complete and adopted. Thank you. Any questions?
Thank you, DJ. We have two people in queue. We're going to ask the speakers to be brief. Srihari, you have the mic.
Hey, Shreel.
Srihari, we do not hear you.
Hello, Jeff, can you hear me?
We can hear you now.
Okay, good. Okay, hey, Dhananjay, this is a good presentation. I've got a couple of questions. One, in one of the slides where you mentioned you can advertise different labels for different encapsulations. It is still, it is considered as a separate NLRI because label is a non-key. Is that right?
Label is a non-key. You would advertise one NLRI, which is the key, which would be the endpoint and color. But if the node that advertised it supported multiple encapsulations, it would encode. It could encode different label, or set values for the different encapsulations.
Okay, that's fine.
And the purpose of that would be to allow, for a migration, scenario where there may be different ingress nodes in the domain, which may either support one or the other encapsulation, but not both.
Okay, all right. Second question that I want to bring up is, this is a good thing that we are introducing the key and the non-key, but I had raised this question on the mailer. It's probably a question more to you and then the enter IDR. This is probably something that the base BGP spec talked about NLRI and the attributes. Now we are going to be looking at some of the attributes will get into the NLRI structure of being a non-key. We may want to have some checks to see how the NLRI can grow with the key and the non-key. Otherwise, we may end up, then the question is, in the next time when we want to introduce an attribute, should we get into the attribute section or should we get into the non-key? That will be a question will be asked every time we introduce a new one. So something that we might want to think through.
I think we agree with you there. I think, and I think even when we, if you see what we've used it for, it has been used to signal, per route, information, not any generic attribute. And we expect that since these are all named or numbered, well-defined, TLVs, whenever anything gets defined, there will be, it will undergo a working group, review, and we, ensure arbitrary things do not get into
So I apologize for interrupting. This question is going a bit long. I have to ask us to move along. Aijun, do you have a brief question? Aijun, we do not hear you. Okay, Kaliraj, unfortunately, we have to ask you. We can hear you now.
Yeah, one brief question. I want to know what's the advantage to use newly defined NLR to differentiate the BGP prefix. Currently we can accomplish the same aim with the color community. So I want to know the difference between two solutions.
I'm not sure. I mean, I understand the question fully because the correctional community is, it indicates, more of the request for an intent, if you will. So it's, we don't want to overload it for the purpose of indicating the intent too. But maybe this is something we can, take up on the list as well.
Yeah, thank you. And I think we will have to defer that to the list. So thank you, DJ. We'll be moving on to Kaliraj's presentation now.
Thank you, Jeff. Can you hear me?
I can hear you. One moment as I load.
Yeah.
Okay, yeah, the microphone.
Yeah, so I'm going to give an update on BGP CT. It's a quick agenda. We'll just recap the problem solution and also explain the mechanics of CT with focus on the key questions that the work group chairs asked and share the changes and current status. Next slide, please. And while I go through this presentation, I'll also clarify the misunderstanding that the previous author had on how the convergence works in CT. So it is not, it does not propagate end to end. I'll explain how that works. So the question is, the problem is simple. It's basically any domain has tunnels. It's just like you call it intra-AS tunnels, and they are varying TE characteristics. And there could be multiple tunnels to the same destination, different tunneling protocols providing those tunnels, and we may need to extend those tunnels, preserving their characteristics end to end across the option C domain. And different routes, service routes want to resolve over them in an intra-AS or inter-AS scenario. So the intent is basically just to do service mapping, and intent-driven service mapping, or you can say constraint-based service mapping. And the solution should be agnostic to whichever transport protocol is in play in each domain and what service layers are there, service layer routes. And one thing that's not mentioned here is it's good if you just separate out transport layer entities and service layer entities in different families. You don't mix them together because they have different requirements, different scales, different speeds. Next slide, please. So these are the main constructs of BGP-CT. Basically, we have a transport class, which is a construct that collects tunnels of the same characteristics, and it has an identifier which is tied to bit, the color. And it's just a new transport layer address family, which follows 4364 procedures and 8277 encodings. Which basically, it uses the existing route distinguisher just as a identifier. It's a distinguisher to carry the prefix across path hiding scenarios, and it can be stripped off, and path selection can be done on it whenever we require. And there is a transport class route target. It's just a new route target which carries the transport class or the color. So color, as the word, is an adjective, so it better is described as an attribute than in the name. And it extends the tunnels across multiple domain boundaries by following option C style procedures and depositing MPLS.0 swap routes on the border routers. And it collects, it basically connects the tunnels of the same transport class in the adjacent domains. And the intent of the route, where to, how to, what kind of tunnel to take, that is carried as a mapping community. And it maps to a resolution scheme, and resolution scheme is what gives the intent. Basically, I want to take a tunnel of a certain class with a certain fallback option. Next slide, please. So in this slide, we have just noted the questions of the answers from the chairs. So where does the intent get carried? The intent get carried on as a mapping community, which is nothing but a regular community on a BGP route. And for example, the BGP-CT routes, the transport target, it becomes the mapping community, and it says strictly resolve over the tunnels of that same type. And for service routes, they may want fallback. So for example, color extended community is the mapping community on the service route. And it would say resolve over color and routes with fallback on best effort tunnels. And for anything else that is like more creative, we can have other communities. Any BGP community can be defined as a mapping community, and it can define the fallbacks as maybe go over gold. If it is not there, go over bronze, and any other mix that the operator wants. And when the route needs to be sent from one intent domain to another, how does the translation happens if they don't agree on the value of what represents that intent? So that's basically just community rewrite. And we can see that even today at service layer, because color community is the mapping community, and this mechanism is just backward compatible to that. So we would do the same kind of community rewrite for even color community on the service routes. So even on the transport routes, we are doing the same community rewrites and route target rewrites as we do in SDVPN networks today. So these procedures are very familiar to operators. And how do we distinguish during pinch points? It's just RD, as we just talked about. RD, and in addition to RD, we also have add path. So it just uniquely identifies the originating PE, helpful for troubleshooting, but we can also strip the RD and do path selection. and how the forwarding semantic is associated with the intent carried in the mechanism. So it does not mention any changes to how it is carried. So basically labels as 8277 or sets in the prefix set, or in future, like multi-next hop attribute proposes to carry labels or other forwarding information as part of the next hop, because these are like the label is going in the prefix, it is actually a next hop attribute. So in my opinion, it is better to go with newer mechanisms which move those forwarding properties to the next hop. And any of those mechanisms that newly get defined, if they are backward compatible to the existing mechanism, that will work with CT. So CT does not expect other mechanisms to change drastically. Next slide, please.
4-minute time check.
Yeah, so this is an example. Using this diagram, I'll explain the question, or I'll refute the statement by Dhananjay that in CT we cannot do what he claimed. So basically, let's say we have PE11. So there are two ways the CT routes can be originated. Either RD colon PE11, PE11 can originate. And in which case the RD colon PE11 route, ASBR21 will know there is multiple paths towards ASBR13, ASBR14. Similarly, ABR23 will know there are multiple paths towards ASBR21, ASBR22. But even otherwise, if ASBR13 originates the route for PE11 and ASBR14 originates the route for PE11, so at each of the ABRs or the ASBRs, these routes are collected in the transport tree. And the label allocation is done on a per prefix basis, where the prefix is after stripping the RD in the context of the transport tree. So that makes sure that the label value does not change and the repair happens locally. So I think they did not understand it right. So we can clarify it more on the list if there is confusion. Next slide, please. So these are the advantages of reusing 4364. We have talked about most of this already. So one thing I want to reiterate here is, say, it protects the investments of operators that they are made in operational training, tooling, procedures, because they already know L3 VPN. And now that same VPN machinery, the route targets, RD is going to play at a new layer. So that's the major advantage of using this. And also interoperability wise, we have ironed out all those problems with L3 VPN, and there is no interoperability problems to be foreseen here because it is just the same family. We have been already using it. And yeah, next slide. So update since the last IETF, we just added the clarification that 5549 type X and next hop capability is not required because it's a new family. So we can state that we can derive the next hop type based on the next hop length. And we added reference to the RSVP subcolor and added a SRv6 support section and corrected some typos. Next slide, please. So the current status is, so basically the draft has been there for 5 IETFs now, and there have been discussions on the working group feedback, and we gathered support organically by these discussions on the working group areas. So thank you for all the discussion support. And the implementation is available since Junos 21.1, and it uses INA allotted code points. This is the point I want to make in the previous slide. So basically, we don't propose any new major extensions in here. So we are reusing whatever mechanisms already work with new INA allotted code points. So the benefit of already existing mechanisms, I think we need to try without inventing new things just for fun. How we can use existing mechanisms, and we have to consider it does not solve. So because this is doing it in an eloquent manner, that is why I think that we have many interested customers who are trying it out in the lab. I think that concludes my presentation. I can take any questions if there are.
Okay, we have again a brief time for questions. Linda, you have the queue.
Two questions. First question, those color, is that consistent across all the nodes? Second question, is it similar to flex algorithm? Like we can use flex algorithm to indicate how does each prefix to be routed? Those two questions.
So flex algorithm is one of the transport protocols in the intra-AS, like FlexAlgo, RSVP, SRT. And each of these transport protocols are taught what their color is. But BGP city is when you're going inter-domain, and then we carry the color as the route target. And your first question about whether the color is consistent on each of the nodes. So in one domain, the color is usually consistent, but it doesn't need to be when you cross the domains. Basically, when we import the route at an ASBR or ABR, that domain border router can rewrite the community to what it means, what is the right value for the local domain. Did I answer your question?
Okay, so you're saying the flex algorithm only works within one domain versus
Right.
this PCT works cross domains?
BGP is for working across domains, and FlexAlgo, because it is ISIS FlexAlgo based, so ISIS is an intra-domain protocol, so it's an extension of that. So I consider that as an intra-domain tunneling protocol.
I see. Is there any reason FlexAlg cannot work cross domains?
So even FlexAlgo or RSVP, we can have multiple domains, and that can coexist with CT. That is also possible.
So
Okay.
Linda, I
Is it
apologize.
duplicate effort? If I use one, I don't need to use another one?
Yeah, you have a choice, yes.
Okay.
Yeah,
Thank
yeah,
you.
Linda, I'm sorry, we have to cut the queue for you. Let the other people get their turn in. Swedish, you have the queue.
Hello.
You can hear
So I can hear you.
Yeah. So question is regarding what you mentioned about the local convergence. As you mentioned, the RDs of convenience. So when you receive two different RD routes, though they are pointing to the same endpoint, on an ABR, when you remove the RD, so that means you have to still map the transport target. That means you have to do an import. And then that means you're doing an import procedure on an ASBR. And second part is, once you allocate a label, you are allocating a label for an IP prefix now, not for the RD comma endpoint. And therefore, the local label would be same. Now, even though you are advertising two routes to the upstream, they are going with the same label. It's the same LSP. So I don't see advantage of advertising two routes, even though they are carrying the same LSP information. So to me, this looks like a hack to just make a local convergence work. I don't think this is with the VPN, this is not the way it works. You just made it because you require local convergence now. Otherwise, I don't see
so
the way.
Basically
You're carrying a hacking information of same label with the two different RD information.
No, I wouldn't see it that way. Let me respond. So basically, we collect the routes in a transport trip for two reasons. For the main reason is because we need to do the service mapping information, where we need to resolve the routes over tunnels of a certain kind. And CT already collects them in a transport trip and gives you. And in car, I think that point is just left out. It is up to the implementation how they organize it, and there is no way the protocol itself organizes it. We just take advantage.
No. I think let's not. I think let's. It's in car. E comma C get resolved over N comma C, right? C in the transport use the same C. It could be FlexAlgo, it could be SR policy, anything. But the question comes, even though you are preserving the RD of two routes, what you are carrying is the same label. So it's the same LSP.
Yes, so let me explain.
Advantage of carrying that information. I just want that answer. Nothing else.
So basically, the prefix allocation is on the scope of the IP prefix, comma transport class. So that is not a hack, but it is just a prefix allocation.
Kalira, you are carrying two routes with two different RDs, but exactly same local label. So it's the same.
Yes. So basically, there is nothing that stops us from advertising multiple routes with the same label because they share the same forwarding semantic.
But what's the advantage? I know that nothing stops you can carry as much, but I don't see an advantage of it. You can carry. I don't know. Nothing stops you, but it's a hack. Ideally, I would have.
No. The advantage is that you are telling the presence of ABR 1.3 and ABR 1.4 to the upstreams. If you don't carry if you don't carry both of them, then if one ABR 1.3 is down, then you will have to wait for BGP convergence. Right?
Yeah, that's what I'm saying.
Until ABR 1.4.
RD-based solution has a problem, right? Right away you answered. You need an import, and then even though you are the two RD routes, it's still the same LSP information. That's what I want to bring up, but it's fine.
I apologize for interrupting. We're unfortunately very tight on time now. This is definitely an interesting point, and I strongly recommend that please post this to the mailing list so it can be answered in detail.
Sure.
Haibo, you have a very brief amount of time.
Oh, can you hear me? Okay.
Yeah, you're heard.
Okay. My question is that now the VPN routes use the next hop and the color to match tunnels. But the CT is the key. NI key is the RD and the prefix. So we must support the VPN route to steer into the tunnel. But so we also need to generate the CT routes to make tunnel use the prefix and the color. So I think it's the key is not exactly a match. I think it may cause some confusion.
I did not understand your question. Are you saying that if we did not have tunnels of the same color, then the route will not be resolved?
Yeah, because the roads, VPN roads use the net hop and color, but the city key is not.
So the way the resolution works is the service route, it asks for resolution using a resolution scheme, which says, let's say, give me a tunnel of color gold or best effort. So if he has a tunnel of color gold, that could be either an intra-domain tunnel, like FlexLGO, RSVP, SRTE, or it could be an inter-domain tunnel, which is a CT route. And if it is there, it will resolve over that. Otherwise, it will go over a best effort tunnel. And the best effort tunnel could also be an intra-AS or inter-AS. If either of these are not there, then it will not resolve.
Okay, we think I think we may discuss it in the mailing list later. Okay.
Sure. Thank you.
Okay, thank you. And Sue mentioned we're planning on having interims on a number of topics. This is one of them. I'm in the process of trying to find your slide deck number 4. One moment, please.
Jeff, while you're doing a discussion, I think we'll schedule this. Sounds like this is an interesting topic for an interim in September.
Okay, I'm going to have to share via screen because I'm not seeing it in the meeting materials for some reason. So for the slide deck, I apologize for clunkiness.
Jeff, I believe the settings somehow got reset. I think if you go through the settings again, it will work.
I did not see it, unfortunately, so.
Yeah, we can continue with this. Maybe we can go to the first, we can skip the first few slides because we lost some time. So here, what we are going to talk about is a problem in seamless MPLS networks, which is like two problems mainly, the scaling problem and the convergence problem. So whenever you have a seamless MPLS network like a BGP and U network, the number of MPLS forwarding routes and next hops on any border node or service node is proportional to the number of nodes in the network as well as the number of ECMP next hops. So that is the scaling problem. And the convergence problem is that when PE goes down and that reachability withdrawal has to be propagated until the other end of the network before PIC or any such mechanism can happen. So we're going to solve these two problems by using a new mechanism called MPLS namespaces. So that is the goal. And next slide, please. So this just describes the scaling problem with an example of these two regions. What the left side region has like 100 PEs, and it just says that we have state proportional to the number of PEs in all the border nodes and the service node. Next slide, please. And this explains how when PE1 goes down, the update has to be propagated to PE2 prime before PE2 prime can do prefix independent convergence towards PE2. Next slide, please. So the way we are solving this is a new BGP family. It is nothing but, again, an L3 VPN design pattern has been reused to form a labeled VPNs. It's basically just like IPVRFs. we have, you can say, label VRFs. And this is done to be able to do upstream allocation of labels in MPLS forwarding context at a receiving node. So this family needs to be negotiated just between the RR and the border nodes of a particular region, and that will help the whole network scale up and the convergence to be faster. So the way it happens is, maybe we can go to the next slide and I'll explain it along with that. So this one region is identified with a context protocol next hop, and we hide the actual protocol next hops from getting advertised towards the other regions in the service routes. So when the RR re-advertises the service routes to the other regions, it rewrites the next hop to the context protocol next hop, and it can allocate new labels and install them in the context tables at BN1 and BN2. And the way it installs those labels in these context tables is where this new BGP family is, it plays a role. And now, because the RR is deciding what labels to use, RR can use static labels, predictable labels, or anything that it can basically do anything. And we are increasing the label space that is available in the network. So here, what happens is now the right side of the network or the remaining regions, they don't see these 100 loopbacks, but they only see one context protocol next now. So that is how the forwarding resources at the border nodes and the rest of the ingress nodes is saved. Next slide, please. So when we do this, the benefit is that when PE1 goes down, PE2 prime does not even know about it, because the failure action is taken by BN1 and BN2, which is like in the same region. So the failure is very quick. So as you can see in this diagram, the private label PLCE1, it is having an active and backup towards PE1 and PE2. And when PE1 goes down, BN1 and BN2 will just do a repair, as shown in the next slide, please. And the traffic will be repaired towards PE2. So the withdrawal does not have to travel until PE2 prime, because the failure is taken care of locally. And similarly, even if BN1 fails, in the next slide, because the labels have been mirrored in these context tables at BN1, BN2, so once PE2 prime sends traffic towards the CPNH1, it will reach either BN1 or BN2 based on the local repair or local region repair that happens in the BN3, BN4. And irrespective of which node it comes to, the private label will make sure that it goes to the right PE. So this way we are able to do kind of a mix of egress protection and BGP pick, which is like at a layer which is not, it is not dependent on the service layer. Next slide, please. So this is like a new kind of option, inter-AS option, which is like a combination of option B and option C. So we are getting option B forwarding behavior with some additional advantages of label mirroring, and which gives us the scaling advantage and the convergence advantages that we see. And as I already mentioned, PIC and egress protection, like convergence features, they work in this model for any kind of service routes. So PEs and the PEs don't need to support anything. It's only the RR and the border nodes. And this works with legacy PEs also. There is no upgrade required on any other part of the network. So that seems very powerful to me. So I just wanted to present this, and we have some working code, but there's not much progress that we have made with socializing this outside in IETF or vendors or other co-authors. So I just want to present it here and seek for support, ideas, comments, co-authorship, everything. Thanks.
Okay, and again, we're running a little bit behind. Swadesh, you have the microphone.
So few questions regarding it. So in the typical, let's say on your left domain, which was the region you were trying to hide, and you have 1,000 verves and you have 100 Ps, how many CPNH contexts you see on those BNs?
So let's say, so it will be a function of how many service endpoints are there on the left side. So even if you, for example,
service endpoints within the verve or service, because service endpoints means you're talking about 1,000 verves here. I told 100 Ps, 1,000 verves configured here. Then what do you mean by service endpoints?
So it will be like number of CEs, for example. So the RR can...
Number of C's into number of verbs?
No, just number of C's.
Okay, then that means RR is doing something like an option. RR has, you have moved the option B control plane to an RR.
Yes, yes. So basically, we have a customization possible.
MPLS labels now, correct?
Correct. So we have a customization possible at the RR. For example, there are different forwarding modes, label allocation modes. It can be either per next hop or per table, or it could even be per prefix, right? But
so you have to understand on the RR, you're not aware of the CEs. So you have to send a community or something else, or you have to look at the receive label. You have to look at the receive label and the next hop combination to do allocation. So it's not that.
Yes.
And to me, this looks like an option B. On the RR, you will start doing an option B control plane where you start allocating a label for an RD comma prefix, and then you downloading that label table to an BN router, and on BN router, you're allocating a CPNH label just to come to that table, whatever table you have created.
Exactly.
Right.
Yes. Yes.
So, but
everything is right except for the label allocation part. Label can be allocated for some logical construct.
So why not?
It's not always.
So why not option B running on the BN itself and just allocate a CPNH for that table? Why to have to do from RR? Why to make RR complex of being label allocation?
So these roles are actually, it can be moved anywhere. So the role of the external allocator.
I wouldn't like an RR because RR carries so many address families. I would have loved to do this thing on the BN itself, where it's an option B. It's an existing profile. The only thing is you are creating a hierarchy where if you want to go to a table, I will advertise a CPNH. Now the question comes, how many such tables will it help you? If there are 100 P's, there were 100 loopbacks you're advertising. Now with 1000 verbs, will you advertise 1000 such CPNH, or you're still optimizing there?
No. The CPNH is for the whole region. So the context table is for the whole region.
Now, if it is for the whole region, that means you have done an option B control plane on an RR, and you're downloading whatever labels you allocated per RD, per prefix, whatever allocation scheme you use, using an MPLS this route to this. I'm not sure it's on RR you would like to do something like this. I will leave it to the working group. But I would have done something like this on BN, but let's.
You can view this RR as a type of controller. It just gives you the ability.
So we're out of time, and again, the conversation's obviously heading an energetic point. Please continue it in the mailing list. I think this is going to be a good thing to actually discuss.
Thank you for the discussions.
So we have one further presentation that will have to go from the unfortunate way of presenting, and then after that we have the converted slides. Reshma, you're up.
Yeah. Hello everyone. My name is Reshma, and I will be presenting the generic metric TLB for AIGP, draft on behalf of all the authors listed. Next slide, please. Today I'll be talking about the draft problems we are addressing, our interpretation of RFC 7311, the new generic metric TLB updates to the best path selection, followed by an example. So let's begin. Next slide, please. For interdomain path selection, we use the IGP cost to get the end-to-end best path. We carry IGP metric of a particular domain in BGP using AIGP attribute. So the value carried in the attribute plus the cost to reach the next hop is used in BGP when selecting the best path. Currently, AIGP attribute only talks about the type 1 that carries the default IGP cost. Now, there's a definition of a generic metric type that can embed multiple metric types within IGP. This supports both standard metric types and user-defined metric types. The metrics can be based on latency, bandwidth, traffic engineering, default metrics, etc. So AIGP attribute needs to be extended to carry these metric type, and we propose a generic metric TLB that has direct mapping to the metric types in the IGP metric registry. Next slide, please. So before we go talk about this, RFC 7311 mainly talks about the AIGP TLB, which is type equal to 1 in the AIGP attribute. So it makes certain statements regarding AIGP TLB. We just want to highlight these and note our interpretations and how they are mapped to different types. So RFC 7311 says, when an AIGP attribute is created, it should contain no more than one AIGP TLB. It also goes to say that if it contains more than one AIGP TLB, only the first one is used. Any other AIGP TLBs in the AIGP attribute must be passed along unchanged. So our interpretation is that for any other type that is recognized, like type 2 or type 3, it should behave similarly. RFC 7311 also says that the AGP attribute must not be considered to be malformed because it contains more than one TLB of a given type, or because it contains TLBs of unknown type. So here the RFC clearly states that if we recognize a TLB type, process and update it. If the TLB is unrecognized, it does not clearly state how it should be processed. It just states that unrecognized TLB should not be treated as malformed. Next slide, please. So this is the new generic metric TLB. Like AIGP TLB, we have the type and the length. So here the length would be assigned to 12. And the value field has been divided into two subfields. The metric type, whose value maps to the IGP metric registry, and the metric value, which is a 64-bit value. Next slide, please. Okay. See, the origination is similar to RFC 7311. Advertise only if it's configured to advertise AIGP attribute. If the domain uses any metric other than IGP cost, then use the new generic metric TLB with the metric type filled according to the IGP metric type registry, and the generic metric value indicating latency or bandwidth to reach the prefix being advertised. On the receiving end, we act again according to RFC 7311. Like that, we should be enabled to receive AIGP attribute from the sender, among other things. On receiving, we check if the metric type received matches the domain's local metric type. If so, use the received metric to calculate the enhanced AIGP cost. If the domain's metric type does not match the type of the metric in the generic metric TLB, then we need to normalize the metric or cost to reach the next stop to the received metric type in the generic metric TLB, and then calculate the enhanced AIGP metric. Next slide, please. So the best path selection is similar to the RFC 7311. A path with a generic metric TLB is preferred over paths without a generic metric TLB. Say we have route R with T as the received generic metric value. If the received metric type matches the metric type to the next stop, say N, then the enhanced AIGP metric is T plus N. If the metric type doesn't match, then we need to normalize the metric to reach the next stop to the received metric type, and then calculate the enhanced AIGP metric type. So if we have received two paths with different metric types in the generic metric TLB, then they cannot be compared, like if it's different metric types. So we propose that the lower metric type must be chosen as the best path between them. Next slide, please. So taking an example, so let's just, for our example, let us assume that within the domain, everyone has the same metric type. So here in this example, domain 4 and 3 has delay as the metric, and domain 1 and 2 use IGP cost. So when advertising route from domain 4, ASBR 41 advertises the generic metric TLB with metric type as delay for in the IGP metric registry it is 1 to ASBR 22, and in ASBR 42, and ASBR 42 advertises same to ASBR 32. So on receiving, ASBR 32 can add the metric to reach the direct link to ASBR 42 and then advertise it to ASBR 31. And on ASBR 31, since the domain uses delay as the metric, and what we received in generic metric type is also delay, it can just simply add and then advertise it out to domain 1. On domain 2, as ASBR 2 at ASBR 21, the cost to reach the next stop, ASBR 22, is represented by IGP cost. So we need to normalize this. Say if delay is not like a significant factor within domain 2, then you can add 0 to the received generic metric value and advertise it. So the metric type is normalized to the one set by the originator. Next slide, please. Okay, I think it's a bit okay. So we have covered this in the slides previous, that recognized TLB is processed and sent. Okay, next slide. Yeah, I'm just opening the forum for any comments and questions.
Swadesh, you have the microphone.
You are saying the metric type is decided by the originating domain, but as you see BGP CT or BGP car, the intent is carried in the certain community, or in a car it's carried in the NLRI. So metric type looks very, it's weird that you are decided by the originating domain what metric type to carry, right? It's interesting. Some more granularity or some more important things to look into before that. Because your intent is carried in the transport target or in the color. Now, if intent is carried there, now if you're deciding by the origin domain what to carry in the type of metric, they may not match because intent may be somewhere else you were looking for in some other domain.
At the end, we are carrying an IGP cost, right? Which is from the originating domain, right?
Yeah, if you're, then I'm saying if you're normalizing that way, then we could have used AIGP, today's AIGP TLV. I'm not sure what advantage we are getting with introducing this generic, if you're looking that straightforward then.
We have other co-authors at the microphone.
Shraddha, you want to take that? Shraddha? Yeah.
Hello, can you hear me?
Yes.
Yes, Shraddha.
Yeah, so so I think Swadesh's question is why do you need different metric types? So if you're advertising two routes, one for low cost and another for low latency, so you just carry the low cost in the AIGP for the first route, and you carry the latency in the second route. So the problem here is what we're trying to do here is match the metric types, because you need to add. So let's say you have multiple domain. You need to add the delay metric. For the route which is carrying delay metric, you need to add the delay metric along the path. And for the route carrying IGP metric, you have to add IGP metric along the path. And it may also so happen that in some domains there is no delay metric for the route, no delay metric at all, no delay metric paths at all. So you're falling back on best effort. You have to make that distinction, what metric type you're carrying and whether you want to add it or not. And that is easily done by having the metric type match onto the IGP metric types, so that you know what metric type is being carried and you look at what you're resolving on and then make a decision whether to add directly or normalize the metric and then add it. So
are you saying your intent is carried in the metric type now, in some sense?
No, so intent is still carried in for example, for if it goes in BGP CT, it goes, intent still goes in route target, and the metric type that is used for accumulating is carried in the metric type. So metric type is not the full intent, right? Intent can be much more. Metric
Intent
type is just part of the intent.
Intent is just superset. I completely agree. But I'm just trying to bring out a point where you are carrying, I agree, they are carrying a metric type, but there's a disadvantage. I can't see still, because you have to normalize that information when you go over some other different types. So why not carrying a AIGP only, what we have today? Why, if with something what you're proposing, I haven't seen the advantage yet of it, correct? AIGP TLV will give exactly same thing, accumulated, normalizes, sent across.
Yeah, this is carried in all the, AIGP is carried in all the families, not only BGP CT or it can go in service families as well. And it has the same semantic as what 7311 defined, right? It can go in any family.
Yeah, that's what I'm saying. It's exactly the same. So therefore, I'm trying to just understand the advantages we are gaining out of it. Yeah, I see there's more information. I agree, but advantage I'm still trying to evaluate.
Yeah, maybe we can discuss over the list. Srihari is also on the queue. I would let him.
Let's discuss over the list. Sure.
Yeah, I think Shraddha you've answered, so maybe we can discuss on the list.
Sure.
Okay. Thank you for giving us time back, and thank you, Reshma, for the presentation. Okay, we will hopefully be back to the good tools right now. So Giuseppe, I believe you're the presenter.
Hello, everybody. I'm going to present an update on this draft that is about the BGP SR policy extensions for IP. So next slide, please. Yeah, just a few words about the background and motivation. So IFET refers to data plane on path telemetry, including in situ OM, and you have the reference document that is last call and alternate marking, and you see the two reference RFCs. In general, you know that an headend may be informed about the candidate path for an SR policy by using BGP, and there is the document in working group plus call. Indeed, this document aims to define the extension to BGP to distribute SR policy carrying IFET information. In this way, the SR policy, when the SR policy is applied, the on-path telemetry method can be enabled automatically. Next slide, please. Yeah, in this slide we highlighted the main changes from the 0.1 version. So according to RFC 8799, IFET is a solution that focusing on specific network domains, and we highlighted in the draft that for a number of reasons, such as policies, options supported, network management, and security reasons, it is suggested to limit IFET techniques to a controlled domain. Based on this requirement, we also improved the security considerations part, in particular to highlight that the IFET data must be propagated in a limited domain, and this is also done according to the security requirement or the relevant in situ OM and alternate marking graph. Next slide, please. Yeah, this is a recap about the IFET attributes in the SR policy. Yeah, the SR policy encoding structure is aligned with the draft IETF IDR segment routing key policy that, as I said, is in working group plus call. We just add the IFET attributes as sub-TLVs, and we define 5 sub-TLVs related to in situ IM and alternate marking. Next slide, please. Yeah, in this slide, we show the 4 relevant in situ IM sub-TLVs related to IOM pre-allocated trace option, IOM incremental trace option, directly export option, and edge-to-edge option. And so we have 4 types for this. Next slide, please. Yeah, and this is the type 5 about the alternate marking sub-TLV. We also added 2 new flags to indicating that the measurement is op by op or end-to-end. Next slide, please. I guess it's the last one. Yeah. Yeah, so in short, this document simply complements the SR policy operations as described in the companion document on segment routing key policy by adding the IFET attribute. We are working on this to make the draft stable. For example, according to the reference document in 6 months, we added the consideration of controlled domain and so on. So of course, questions and comments are welcome. Thank you.
We have time for a brief question if there is any. Okay, thank you, Giuseppe.
Okay.
The next slide will be point to multipoint policies.
Yes, I can hear me.
Okay, you can hopefully see the slides.
Perfect. So I'm going to try to make this presentation shorter. I'm sure some of the folks here have heard this in the BESS. I don't want to bore anybody. But the entire purpose behind this point-to-multipoint policy was to come up with a BGP operation, if you will, to download point-to-multipoint LSPs from the PCE to the PCC. We wanted to keep it in par with the point-to-point SRTE. Some of the vendors out there are already using that. There are some implementation of that out in the wild. And we wanted to keep this draft very much in line with the point-to-point SRTE policy. Next slide, please. So these are some of the drafts that you folks can go through and have a read on with regard to the point-to-multipoint policy. There's a replication segment that's basically the forwarding entity. And then there is the policy itself, which the candidate paths and path instances reside under the policy. I will go through them later on. There is a Yang model, which if you have a look at it, it will give you a better understanding of how the models, the replication segment, the point-to-multipoint policy is working. And obviously then there's an overlay, which is the MVPN, EVPN, SR point-to-multipoint, which is part of the best working group. And we are looking at the PCE for the controller communication to the PCC, and then there is the OEM draft, which is the ping. I don't think you can see it here. Maybe it's below, but anyway, it is there. Next slide, please. So what a point-to-multipoint policy is, a point-to-multipoint policy really contains the root and a set of leaps. It contains a set of replication segments as well. The replication segments, as I mentioned, are the forwarding entities that are programmed into the data path, basically incoming seed and a bunch of outgoing interfaces when you want to do the replication. Your outgoing interfaces can be obviously different interfaces, and then there is a swap that swaps the incoming seed for MPLS, of course, with the outgoing seed toward the downstream node. It is identified via a root and tree ID, which is really the case for most point-to-multipoint technologies out there. And there is two ways to initiate this. There is a PCC initiated and the PCE initiated. So with regard to the PCC initiated, when it comes to BGP, obviously there is no northbound communication from the PCC to the PCE in the BGP as of now. So there could be many other ways of doing it, including using a route reflector where the BGP session is connected to the PCE itself, and the PCE can look at the route, the AD route types, and learn the leaves and the route, if you will, and based on the leaf and the route, the PCE can make a calculation of the tree and figure out based on the algorithm, whether it's SPF or even some kind of CSPF, where the replication segments are, and download the forwarding information via this draft to those PCCs. On the PCE initiated, it's a little bit more simpler. There must be a network manager or the controller that the user goes on it and configures the route manually and says, here are the leaves for this tree. And then the controller actually calculates the point-to-multipoint tree based on, again, the underlying IGP, and downloads the replication segment to the corresponding PCC nodes on the path. Next slide, please. So the policy itself contains a bunch of candidate paths. The candidate paths are a little bit different than unicast. In our case, there is an active candidate path based on the preference, and then there is a bunch of standby or backup candidate paths, if you will. And basically in this draft, we changed that a little bit. I know that in the unicast SRTE, there is a concept of ECMP and wait. And we did introduce that concept in this draft as well. So you could have two candidate paths in this draft that are of the same preference and can be used for ECMP. It's completely optional. It doesn't need to be there, but there is that option if you want to use it. And then there's a concept of the path instances. So each candidate path can contain two path instances. The path instance is really the point-to-multipoint LSP itself. It is the tree. It is what is programmed on the data path. And the reason that we have two path instances is because of global optimization. So if for whatever reason, IGP change or any underlying network change, you want to optimize your tree, you create a second path instance, and you do make before break procedures to go from the previous path instance to the new path instance without losing too much traffic. Next slide, please. So the replication segment, as I explained previously, is the forwarding entities. It contains the incoming seed, it contains a bunch of outgoing interfaces. It can even contain fast reroute information, protection information, which for each one of those outgoing interfaces. You could actually create a fast reroute, a protection LSP via the replication segment itself. So that's possible. Usually you can do that with unicast SR because two replication segments can be connected via unicast SR, or even if they're connected back to back, one of the replication segment can be steered out of the node via an adjacency seed. So really you can use the unicast segment routing, LFA, TI LFA, remote LFA for that protection. But let's assume that if there was no unicast SR in the network and they had only turned on the replication segment and point-to-multipoint policy, you could create a protection path via these replication segments to bypass a node. The replication segment is identified via the root, the tree ID, and the node ID, and the instance ID. Again, keep in mind that each instance ID under the candidate path is there for global optimization. So this is why each instance ID is going to have its own set of replication paths. Now, one thing I want to point out here, and this is a very strong concept, is the fact that two replication segments, they can be connected via unicast SR. So you could have ingress replication, or you can even put your replication segment into places in the network when there is only replication needs, and connect these replication multi-hops away via a unicast SR policy. And when you are in the unicast domain, all the goodies of segment routing, unicast segment routing comes into play. Next slide, please. I'm not going to go too much into detail. I explain everything. This is a visual slide for you folks if later on you wanted to look at it and put all the concept that I just talked about together. The only thing I want to talk about here is that, as you can see, node A and C, that's where the replication policy residing, and node B is a node that cannot support replication policy. And when you're going out of the node A via that outgoing interface, you can steer your traffic into a unicast segment routing policy, and that will take you to the next replication segment, which is the node C. At all points, the replication segment needs to be present at the bottom of the stack. So it doesn't matter how many segments you push on top of that, because you're going into a unicast domain, but that replication segment needs to be at the bottom of the stack so the next replication point can identify that packet to be a point-to-multipoint policy. Next slide, please. Now, again, when it comes to the if you will, SRTE point-to-multipoint policy, we try to keep it very much in line with the unicast big brother. We created a new NLRI, which is the point-to-multipoint policy NLRI, and we created a new SAFI and two route types. The route types are basically one for the point-to-multipoint policy that I explained that previously. The point-to-multipoint policy contains the candidate path and the path instances. And then the other one is for the replication segment, which actually is the forwarding information. After calculating the point-to-multipoint tree, they get downloaded to the PCC via this route type. Next slide, please. So when it comes to the point-to-multipoint policy route type, again, exactly like unicast, it downloads the candidate paths. It can download a leaf list. As I explained, you could have a route reflector which listens to the AD routes on the PCE and builds that tree. And if that's the case, for debuggability, you can download the remote endpoints or the leaf list to the PCC. Again, it's not necessary, that's why it's optional, but just because there is no northbound direction, just in case on the PCC, if you want to see what is your leaf list, the PCE can download this via the TLVs that you're looking at right now. And there are the path instances, and as I explained, there are 2 path instances with 1 path instance being active at all times. Next slide, please. Again, replication segment, same idea as unicast. There is a segment list. You list the segments under that segment list. Each segment list can be an OIF, outgoing interface. There is a concept of ECMP via the BAIT TLV, sub-TLV, which is optional. And we also added the protection segment list, which you can see at the bottom of the screen. That is optional too. The way that the protection segment list works is that we provide a protection ID for that segment list, which can be used by the primary segment list. It actually, multiple primary segment lists can use a single protection segment list to bypass a failure throughout the network. So if you can go 2 slides now. So we presented this in BESS. Again, we are presenting it in IDR2. One point I want to put into on the table is that this is transport. This is underlay. It has nothing to do with the overlay. We are just trying to build a point-to-multipoint tree via this draft. So this is why we thought IDR is the best place to home this draft. And obviously, we are looking for adaptation. Thank you. Comments, questions, please.
Okay, we have time for a couple quick questions. Gian, you're at the head of the queue. Gian? Okay, we will come back to Gian. Huaymo, you have the microphone.
So normally BGP connections to PE, but we don't have BGP sessions to payload in the network, in the core of network. But for SR P2MP policy, we have to send the instructions for replication instructions to the transit node. That's the core P node. So how do BGP to achieve this through BGP?
Yeah, through BGP, but as I mentioned, there is no need to have BGP meshing through every single node within the network. The replication segments can be connected via a unicast SR, which is in most cases that'll be the case. There will be some cases that the replication segments are connected hop by hop, node by node. And in that case, obviously, you need to have this BGP session to every router that wants to listen to this NLRI and the route types for replication segment. So that's another thing I missed in the presentation. I do apologize. The point-to-multipoint policy with the candidate paths, that's only on the root node, on the head-end node. The replication segments, which are the forwarding entities, those are the ones that need to be downloaded on the transit node and on the leaf node and on the root node. So yes, if you want to have replication segment hop by hop, then obviously you need to have BGP session to every one of those PCCs.
Okay, we're running tight on time now. Gian, your question next, please.
Sure. Just a quick question. Would this be supported for inter-AS and also, I guess, SRv6 support?
Yes, definitely SRv6 is there as we have introduced it into the main drafts, into the architectural drafts, the replication segment and point-to-multipoint. And with regard to the inter-AS, I don't see why not. Obviously, if the controller has the view of the entire network, then you can go over inter-AS. If not, then you can actually bring in the MVPN inter-AS procedures to start stitching this technology. We need a draft for that. I think that's in the MVPN, EVPN draft. In the BES, we have described how that can be done.
Well, also with the PCE, would you recommend using PCE, like centralized controller, where you have a session to each node, or just the regular PSEP? So, so centralized controller, would that be recommended, I guess, or you have a PCE session?
Yeah. So obviously there is a PSEP, PCE portion of this, which is in the PCE working group. This is the second method to download those information via BGP SRTE point-to-multipoint.
Okay. Thank you.
Thank you.
And I apologize, Lu Yao, we're going to cut the microphone for the next presentation. Thank you for the presentation. I think I'll emphasize from the presentation that we just had, we did have this discussed in BES. There was some discussion, also including Jeffrey Zhang with an overlapping proposal, and that content is definitely worth IDR listening to because it's relevant to what work is going to be adopted in which groups and exactly how the work overlaps.
Hi everyone, can you hear me? Okay, this is Tongli from China Telecom. I will present the content of this draft BGP-LS with multi-topology for segment routing based VTN. Next slide, please. The first part is the background of this draft. There are several terms and basic mechanisms should be declared at first. The definition of VTN has been introduced in the draft. A VTN is a virtual underlay network that connects a customer edge point with capability of providing the isolation and performance characteristics required by an enhanced VPN customer. Secondly, the draft IETF Spring resource-aware segments introduce the resource awareness to segment routing and defines the resource-aware segments. The mechanism and produce of building SR-based VPNs are described in draft IETF Spring SR for enhanced VPN. Moreover, the IGP mechanisms for SR-based VPN are discussed in SLR working group. The draft has been adopted by SLR working group. It describes an IGP mechanism to advertise the association between the topology resource attributes and the SRCs for each VTN. Similarly, this document describes a mechanism to distribute the information of SR-based VTNs to the network controller using BGP-LS with multi-topology. This mechanism describes how to distribute the VTN topology and resource attributes to network controller. Addition, the inter-domain topology and TE attributes of VTN are also considered in this draft. Next slide, please. This slide shows the scope of this document. A virtual transport network is a virtual underlay network which consists of a subset of the network topology and network resource allocated from physical network. So when a centralized network controller is used for VTN-specific task computation, BGPL is used to exchange information between the network entities and controllers, and BGPLS can distribute the intra-domain topology, the inter-domain topology, and the associated key attributes of the VTNs to the network controller. Next slide, please. MTID is reused as a control plane identifier of VTN. It is assumed that each VTN is associated with a unique logical topology. This document introduced 3 advertisement mechanisms. The first one is per VTN intra-domain topology advertisement mechanism. In this mechanism, MTID TLV is carried in BGP link NLI, prefix NLI to advertise per VTN topology information. Topology-specific SRCs are advertised by using BGP SR or SRv6 extensions. The second one is per VTN interdomain topology advertising mechanism. MTID TLV with BGP is used to advertise per VTN interdomain connectivity and the topology-specific peer adjacency, peer node seed, and peer side seed. MTIDs need to be unified plan to ensure the consistency both domain and on interdomain links. The third one, next slide, please. The third one is how to advertise the results information also with each VTN. In this mechanism, one link can participate in multi-VTNs. The topology-specific T attributes are used to specify the resources allocated to each VTN. Use VTN ID TLV in link NLI, then the macro link bandwidth sub TLV is used to advertise the subset of bandwidth allocated to the VTN identifier by the MTID. At the same time, the advertisement of other T link attributes per VTN is for the further study. Next slide. There are some scalability considerations. As mentioned above, this VTN is associated with a logical topology. Therefore, each VTN is needed for the independent topology or route computation. When a link or prefix participates in multi-topologies, it may increase the number of BGP updates advertised to the controller. As a result, the MT-based VTN mechanism is applicable to network scenarios where a limited number of VTNs is needed. Next slide. This is the third version of this draft. In this version, the document tab has changed to informational, which is same as the IGP MT-based SR VTN draft. In the chapter 4, we add some text to in order to clarify the scalability considerations. To clarify the applicability of MT-based SR-VTN approach. In addition, a reference document list has been updated and editorial changes has been done. Next slide. We think the content of this document is stable, so is it possible to consider the working adoption of this document now? Any comments and suggestions are welcome. That's all.
Okay, thank you for your presentation. Please note that you have a question in chat from Ketan, and he's yielding mic time. Would prefer that you answer it there. Are there any further questions? Okay, again, thank you very much. Okay, our next presentation, deterministic route distribution. Inka.
Hi there. Can you hear me?
We can hear you. I'm in the process of trying to find your slides in the UI that seems to be moving around a little bit.
All right.
I have found it. Thank you. Please begin.
All right, thank you. Hello, everyone. Yeah, so the topic is deterministic primary distribution into BGP. This is a joint work with my colleague, Jenny. Next slide, please. So this is actually a very old problem. It is a day one issue. It exists in a number of implementations. I'm starting actually with the point number 4 on this slide. And it requires a configuration if one is aware of the issue and aware of the solution. It can be very frustrating in network operation as I had if you are not aware of the issue. And because it's random, it's non-deterministic. So the issue is this: we have basically a non-deterministic behavior when we redistribute a backup route into BGP. The primary and the backup, of course, from a router's point of view, it's or from the routing table FIPS point of view, it's based on the admin distance. When you compare different the routes from different protocols, you use admin distance. So when you redistribute, this route is supposed to be a backup. When it's redistributing to BGP, it depends on the ordering, which one arrives first. So you are comparing a local route versus a BGP route. Which one arrives first? Then it can result in non-deterministic path selection. So basically, it's the root cause is this. We basically have conceptually there are two tables, right? One is the RIP, or we call the routing table, which is where you group routes from different protocols and you use admin distance as a tiebreaker. And then you have a BGP table. It has its own path selection algorithm, as we are all familiar. It basically starts with a local pref. There's also a weight that is sort of that is vendor specific, and it's also there. So you have weight, you have local pref, you have AS path, and other attributes. So these two are not correlated. If it's this guy is the best in BGP, it's not propagated. It's basically the other way around. Let's say the backup route, right? Locally, it's based on admin distance. It's configured as a backup. Once it arrives first, before the BGP route arrives, it gets into the BGP table. Now you are going to compare with the local pref with AS path and with RGP metric. And also in a lot of implementation, you have a local route is more preferred than BGP routes in the BGP path selection. So although it's a backup from this RIP's point of view, but in BGP will become the primary. And when let's say moments later, when the BGP routes arrive, it will not be selected as the best path. As a result, that primary path will not be installed into the RIP and the forwarding. So I will not go into the details of the interactions, but there are several examples presented in the draft. I think with I believe has enough details, for folks to look at. All right, next slide, please. So what is the solution? Certainly, we would like to, correlate these two algorithms, the RIP and the BGP, right? How do we do that? So we basically say, okay, you are the primary or backup, you have admin distance, somehow this admin distance should be reflected into BGP so that BGP and RIP will be consistent. So let's start with the ones with the path and with no admin distance. That this admin distance we know deterministically with what are these paths for the locally redistributed path and for eBGP path and also the one that is aggregated locally. For this type of the routes, basically, certainly we know the admin distance, deterministic, we know that. Let's start with by basically introduce admin distance in the BGP route selection as the first step prior to the local pref comparison, right? What about, what if you have RBGP routes, right? This is a sort of, we describe as the network-wide non-deterministic behavior. You have a primary at one location on one router, you have a backup on a different route. So this is where, obviously, we do not have any way to actually to convey the admin distance or the sort of that preference directly across the network, right? Then we basically, but we have something else in BGP that is called the local pref, right? So we can use local pref to have a network-wide influence. So the proposal here is that when you redistribute a backup route, basically you make sure you also lower the local pref so that when it propagates through BGP, now it will have a network-wide impact. So that sort of indirectly, you will have the primary, you will have backup intentions be honored, right? So when we can actually do one step further, we basically, it's really here. You can do the configuration. Certainly, if you understand the issue, you understand the solution, you can, when you redistribute route, you can set your weight, you can set your local frame, you can do all these things, certainly. But here, most people, really this kind of non-deterministic behavior, I think it's actually it's hard to understand. It's hard to figure out why we can do better, certainly. I think the default, if you talk about the default behavior, you actually can calculate the local pref automatically. Basically, here's the algorithm. It's basically proposed in the draft. You basically, when you rank them, you rank the backup in the network. You say, okay, this is my secondary, this is my tertiary. Typically, you don't go beyond that, but although algorithm can work, even with the fourth one. You basically say, okay, you rank them, now you assign an offset. Offset could be a 10, 20, it doesn't really matter. Then you basically say, how do I do my admin distance? This is something you have to do anyway, because you have to compare your admin distance of locally, the local route versus the one that's received through RBGP. You have to do that anyway, to provide the backup capability, right? So you basically rank them, then you basically say, when I assign my admin distance for the backup routes, you basically it's the admin distance plus the offset. Offset you already ranked. You rank them, your secondary, tertiary, you assign 10 as 20, 10, 20, 30, for example. And then automatically we can calculate, admin distance, right? This can be, they don't have to be the same. It's basically in a multi-vendor environment, the admin distance can vary from one router to another router. It doesn't really matter. As long as you follow the algorithm there, it's going to be whatever admin distance for IBGP I have on this router, you apply offset. That is the admin distance for your backup, right? Then you basically local pref, the default is pretty much every common in the network. You derive this, it's going to be the local pref, is the default local pref minus offset. This way, they basically, your intentions, right, for the primary backup and tertiary, they will be reflected and calculated automatically through the local pref. So you will, basically the default behavior will be deterministic instead of non-deterministic, and it would reflect the intentions. Next slide, please. So we basically, we have received a number of very good feedback on the mailing list. I think although we are basically, I think several of us are familiar with multiple implementation. I think it will be great if we can get more feedback, in particular from BGP implementers, basically about your particular implementation, because we want to make the algorithm sort of, because this is a, in our view, is a generic problem. We want to make the solution generic as well, right? So some of the comments are not reflected in the other two versions. So we may expect, to come up with basically a revised version 0.3 with further clarification and editorial changes. After that, we expect to request working group adoption. I believe that's the last slide of the presentation.
Okay, thank you. Unfortunately, we're very shy on time. We have to move on to our last presentation. I do urge the working group to please give this good attention. Changes and things that impact route selection, such as local pref, being set, has very strong impacts on route selection across the network, and we want to make sure that we don't have unintentional side effects.
Yeah, exactly.
Okay.
Thank you.
One moment, and loading last presentation. Okay, Gian, you have the mic.
Hi, my name is Gian Mishra. I'm with Verizon, and I'm providing an update for our RDORF. Next slide. So we've had quite extensive discussions on LIST related to this draft, and since over the last few IETF meetings, and since we have had quite a number of updates to the draft to help provide some clarification, as well as the goals and objectives of the draft and the use cases related to the draft. As far as use cases, we have the intra-AS use case where you have a common RD on all your PEs within a VPN, or a unique RD on all your PEs within a VPN, or a universal RD that's configured, as well as intra-AS. So those are all the variety of use cases that are available with this solution. What sets this solution aside from what exists today related to and the motivation behind this draft is being able to filter at the RD level versus the RT at the RT level, where we have an offending PE that's flooding routes, and being able to have that granularity to filter routes just from that particular PE that is flooding, sourcing the routes. So what this solution does is it provides that mechanism for filtering those prefixes, something that doesn't exist today. Just to highlight, I guess, existing solutions to help with flooding of routes that exist today, and as are recommended in the draft, and we have them listed in the draft. The first one is let's say PEC filtering with a maximum prefix, or doing a maximum prefix per VRF or RTC, and those are all recommendations to be configured as the best design practice. However, with those options, with the PEC filtering as well, maximum prefix, as well as the per VRF maximum prefix, in general, those are set to a high watermark, so they may not trigger until you're actually already in a bad situation where you're getting a flood of routes. And then the last one is the RTC. That one also is a recommendation and is an optimization that allows only the interesting RTs to be advertised from the reflector to the PE. And those are recommendations, but regardless, those solutions still work at the RT level filtering. With this draft, I think what sets this draft aside from existing solutions is that it's able to filter at the RD level. Next slide. So the basic framework behind this with this draft, and really what makes this solution fairly simple, and we've discussed this on LIST quite a bit, but just want to highlight kind of the solution. So when a flood happened, the flood of routes, and let's say we have PE3 in this example, in this scenario. So in this case, we have we have the common RD configured for the VPN between all the PEs, and we get a flood of routes with route distinguisher 3.1. So what happens is PE1 receives that, and it has multiple VRFs VPNs configured on him, and he's getting a flood of routes. So what he'll do, basically there's a trigger mechanism that exists as part of the solution, that if the prefixes exceed 80%, similar to the maximum prefix, then an RDORF is sent outbound. The caveat with the RDORF that gets sent outbound towards the route reflector is that if there are multiple VRFs and certain VRFs are also importing that same route distinguisher, then it's a local context whether to configure the RDORF, and that's at the operator's discretion to configure it or not. If you have multiple VPNs and certain VPNs need to import that, need those RD routes. So in this particular case, where we have VPNs highlighted, and it doesn't require the RD routes even by filtering it, because it's being overloaded. But having this VPN2 on there as well, filtering, doing an RDORF outbound from PE1 towards route reflector doesn't impact VPN2, since it does not need it doesn't need the routes coming from RD3.1. So that's a real, and that's something that we had discussed on list. So it's a really local context as far as configuration of when to use it and when not to use it. On the bottom here we have PE2, and he has the same RT1 with RD3.1. It's being imported into both VPN1 and VPN2. So all the VPNs all the VPNs on PE2 are being flooded. So in that case, he sends the RDORF outbound towards the route reflector, and then the route reflector installs an adjacency rib out and drops the RD3.1. Next slide. This scenario is exactly the same as the first one. Basically the same concept, that you have a flood of routes coming from RD3.1. In this case, it's a unique RD, so it's a different RD per PE. But the same concept happens, that you hit a threshold similar to a maximum prefix threshold on PE2. It actually detects it triggers the RDORF outbound, and then the route reflector installs an adjacency rib out towards PE2. Next slide. In this scenario as well, so this is intra-AS with a universal RD. So you have the same RD configured between all different RDs configured between all the PEs. So in this case, what happens is VPN on PE1, on PE2, it just has one VPN on it, and he's importing the offending RD from PE3 RD1 related to RT1. So he ends up he ends up sending a RDORF towards the route reflector, and then the route reflector installs the adjacency grid out towards PE2. However, PE1, it has VPN1 configured, but it also has another VPN that requires the routes. So PE1 does not send an adjacency grid out to, does not send an RDORF towards the route reflector. So the local context of the configuration is really dependent, and that's part of the operator discretion. If you have multiple VPNs, and if all the VPNs do not require the route distinguisher, the prefixes that are being flooded, and in case whether they are all being flooded or let's say there's one, it's really at the discretion on that particular box whether you perform the RDORF outbound. Next slide. In the inter-AS scenario, so in this scenario, what happens? So here we have a P3 is flooding RD3.1, and it's common between RT1 and RT3. So in this particular case, we're seeing a flood of routes coming in from RD3.1, which is common on two different route targets, two different VPNs. So VPN1 and VPN3 are being flooded on PE1, and on PE2 we have VPN1 and VPN2 being flooded. So both in this scenario, both PE1 and PE2, all the VPNs on PE2, I guess, is a good example. So you have PE2, all the VPNs are being flooded, but PE1, only 2 of the 3 VPNs are being flooded. But VPN2, it's not being flooded, but it it doesn't need to communicate with RD31. So even if RD31 is dropped, it's not going to impact VPN2. So here, both PE1 and PE3, PE2, they both send an RDRF outbound to the ASBR. And now the ASBR, he's taken the next step. Since all the downstream PEs do not need the, have sent an RDRF towards the ASBR now is able to send a RDRF toward the ASBR2, towards a source. Next slide. So in summary, the RDRF message, it's triggered automatically based on a percentage. So percentage similar to the maximum prefix configured on the PEC, or I guess you could say similar to the maximum prefix globally on the verse level. So when that trigger happens, let's say it's an 80%, the trigger happens, the RDRF is sent outbound, and then the adjacent box out of the route reflector ASBR sets the installs the adjacency rib out towards the box that's being flooded. So the RDRF message, it follows the following conditions. So what we talked about, it's on the PE. As long as all the verbs do not require the route distinguisher, the PE that's actually flooding the routes, then we send the RDRF outbound. And then on the route reflector, same goes. As long as all the BGP clients don't need to process that route, the RD, the offending RD. And then ASBR, same thing does the ASBR. All the BGP peers within the AS don't need to receive it. Then it propagates it. So in that scenario that we went through in the previous slide, as long as all the PEs within that local AS do not need to receive the offending RD, that RDRF is via the route refresh is propagated from one AS to the other to be installed on the adjacent ASBR within the other AS. The removal withdrawal process is manual, just to avoid any possible flopping issues that could possibly happen. Next slide. So I think the goal of this for the presentation today was really, we've had a lot of discussions on lists, and I'm hoping that during today's discussion, just going over the draft, I clarified any misconceptions and I think any gaps that exist with this draft. And if there are any, we'd like to address those. But we feel, the authors, we feel that this draft has matured. We've provided a lot of updates to the draft, and we feel that it's ready for adoption. Thank you.
Okay, we are at the top of the hour and have time for a brief question or two. Okay, there seems to be no questions. So a reminder to the working group, we have an interim scheduled for August 23rd to discuss this topic in particular. So that's a great place for us to have more in-depth discussion about that, and certainly take it to the mailing list as well. Thank you again. In follow-up, we have a second IDR session for the second session on Friday. So we will be having some additional agenda items there. I'm going to pause now to see if Kay or Sue has anything else to add.
I'm good, thank you. Thank you, Jeff.
Jeffrey, on the next call, I know I had one more that was, I think, I wasn't able to discuss because we ran out of time. Do you think on the next session we may have some time? I guess if we do, if I could, discuss that last item that we weren't able to discuss, the 4 PE.
This is Sue. If we have additional time, we'll try, but we're tight
Understood.
on that. Am I terrible? So
I can hear you.
We'll put
Understood.
at the end of that one, Guyan.
All right. Thank you. Appreciate it.
Okay. And I have nothing more to say. I will send out a drop adoption list. If I miss your draft, please kindly tell me that I have missed your request for adoption. Thank you.
Okay, thank you everyone. This ends our first session of IDR for IETF 111. Everybody have a good rest of your planetary rotation.
Thanks.